So this was another one of the questions that you guys asked on the help box. Really, it's just looking at taking the derivative of logs. So what I really want to make sure that we're reminded of is that if we had a function, let's say f of x equals ln of x, we know that f prime of x, the derivative, would be 1 over x. All right, so the derivative of natural log is really 1 over whatever that is. So when I'm looking at this one over here on our left, I'm noticing that, first of all, there is a natural log that I'm going to have to take the derivative of. But there's also an internal function inside of there. So I'm going to have to look at this in terms of layers. And so I've got that internal function, and then I've got, their outer function. And that internal function, when I look at that one, I notice that there's a product, so I'm looking at the structure. That makes me think product rule. And then on top of that, so yeah, there's that product. And then in addition to that, in part of that product, I'm even realizing that square root, I'm going to have to use chain rule inside of there too. So this is pretty sloppy. I get it. So I guess before I do this, I'm just going to go ahead and rewrite it so I can see all of this stuff. So I'm going to write, like y equals ln, and no big deal. I've got x multiplied by, but I want to view that x squared minus 1, not so much as being the square root, but as a 1/2 power. I think that's just going to help me by the time I get there. So, and again, I'm going to circle kind of my layers. So I take the derivative of this, and then I'm going to need to take the derivative of the internal part, which is actually a product. But then as part of that product, I'm going to have to use, chain rule again, right? So when I get to that purple, I'm going to use chain rule. So let's go ahead and start taking a look at this. I know the derivative of natural log is just 1 over. So I'm going to have 1 over all of that stuff. And I can go ahead and write that down. No big deal. So I've got all of that. And then I need to multiply by, and this is a product, right? So I've got that product. So I'm going to need to use a product rule. So I've got derivative of x is just 1, and it's going to be multiplied by x squared minus 1 to the 1/2. And then I've got add x multiplied by the derivative of the other stuff, which again, now I'm into that whole, I have to take the derivative of the purple, which means I'm going to need to use chain rule, right? Because we've got layers there too. So I've got this layer, and then I've got this other layer. So I'm going to multiply by 1/2 of x squared minus 1 to the negative 1/2, right? Because that's that outer layer, something to the 1/2 power, multiplied by the derivative of the inner layer. And all of that purple is just really the derivative of the purple stuff. And that ends my product rule, which really ends my derivative as a whole. So, this is all y prime. Now, I know this is a sloppy mess. Ultimately, I could use it right now, or I could try to my best to clean it up if I'd like to do that. So I'm going to go ahead and just look and see what I can clean up. I'm going to write it all as one fraction. So I know I have x squared minus 1 to the 1/2 plus, and if I collect all of those things, this is nice because that's going to drop out. So I have x squared multiplied by x squared minus 1 to the negative 1/2. And this is all over x times, x squared minus 1 to the 1/2. And so this is all my y prime. Now, with this, something that stands out to me is this term, in all of them. The only downside is, right, if I look at it, this one is a negative 1/2 power, so it's not going to easily cancel. Now, I could do a whole bunch of different things at this point in time. I could break this up into 2 fractions. I could go here and here. I could just try to get this thing, that 1/2 power, out of the denominator. Because if I could make that become a 1 power, I could make that become a 1 power. Maybe I could make that become some whole number power. So I could do that. Yeah, I guess those are the 2 options I really see for me. And if I really think about this, that 1/2 power is really a square root, right? So I don't really like square roots in the denominator. Let's go ahead and get rid of that because, ultimately, again, think about it, it's really this. So to get rid of that square root, I could really just multiply by, this term in the numerator and denominator. Or, it's really just x squared minus 1 to the 1/2 power. So I'm going to go ahead and do that. If I multiply the top, everything in the top by x squared minus 1 to the 1/2 power, and everything in the denominator multiplied by x squared minus 1 to the 1/2 power. But I realize if I distribute that through in the top, I'm really going to end up getting, x squared minus 1 to the first power, right? Because 1/2 plus 1/2, I know my exponent rules. I'm just going to leave that. And then I'm going to have x squared multiplied by, well, and this is a negative 1/2 power, and that's a positive 1/2 power. So I know that those, my exponent rules again, they have the same base, and so I'm just adding my exponents, which would be a 0 exponent, and anything to the 0 power is 1. So that's nice. That's just going to kind of cancel out. And then in the denominator, I'm going to have x multiplied by, and again, I kind of repeat reasoning here. I'm going to get that one. So this looks way better. As a matter of fact, I can go ahead and clean up that 1 right there, so that's not so bad. So this is my dy dx, my y prime. And I guess when I'm looking at this, well, I could go ahead and simplify the top. I could write it as 2x squared, right, minus 1 all over, I don't know that distributing out that denominator is going to make it look any better, I mean, I've combined like terms in the top, but I don't think that bottom's going to improve at all. So I probably would leave it right around there. If you think about this is pretty usable. If I was, say, trying to find dy dx at x equals 2 or something, it's pretty easy to plug into this one versus that original form, which would have been hideous. Think about plugging it in there. Or even this form, where we had so many half powers. I think that bottom form is just better. It's going to be easier for us. So anyway, I think there's a whole bunch of derivative rules here, but then also a lot of algebra. So hopefully this helps.